Hey guys, and welcome back to another video. In this video, we will be deriving the sum difference identities and the double angle identities for trig functions. Alright, so let's get right into it. Alright, so first we will start by deriving the identity for cosine of a minus b. Alright, so to begin with, let's look at the unit circle. Alright, and so now suppose we have 2 points on the unit circle, point P and point Q. And we know from a couple of videos or a few videos ago that we can rewrite the coordinates of a point on the unit circle as cosine theta sine theta, right? So suppose that this angle right here is A, and then this angle right here, this whole angle, this is B, right? So then that means that P has coordinates cosine A sine A, and Q has coordinates cosine B sine B. All right, and we want to find the distance between QP. So you want to find this distance right here. And it is, so this distance is not the same as the arc length because the arc length is like the curved distance, but we want to find like the linear distance from Q to P. All right, so for that we can simply just apply the distance formula. So we know that the distance formula tells us that the distance is equal to the square root, and then we do cosine A minus cosine B squared, and then sine A minus sine B squared. All right, so then we can simplify this. So expanding the binomial, so we get cosine squared A minus 2 cosine A cosine B plus cosine squared B, and then we have sine squared A minus 2 sine A cosine B, and then plus sine squared B. So that's all under the square root. And so then now we can group the cosine squared A plus sine squared A, right? Because cosine squared A plus sine squared A, that's equal to 1. And then we have cosine squared B plus sine squared B. So that's also equal to 1. And so then this is becomes, and I'll move the square, I'll square both sides so I get rid of the square root. So I have a distance squared, and that's equal to um the 1 plus 1, which is 2. And then we have minus 2 cosine A cosine B minus 2 sine A sine B. All right, and then we can factor out a 2, so we get d squared is equal to 2 minus 2 times the quantity cosine A cosine B minus sine A sine B. All right, so this will be like our first equation for the distance, right? So now let's rotate this triangle we have right here, right? The triangle formed by the origin Q and P. We can rotate this triangle so that the Q thing, the Q side, now lies on the x-axis. So basically, we now have Q is right here, and then we shift P down to like right here, right? So what are the coordinates of Q? Well, it's on the unit circle on the x-axis, so that means the coordinates are just 1, 0. And so then now we must find the angle in between, right? So if this whole angle is B and then this angle is A, that means that the angle between Q and P must be B minus A, right? So this angle right here, the angle is preserved when you rotate it, so it's the same angle. So this is still B minus A, this angle right here. And so then again using the cosine comma sine, that means that the coordinates of P is cosine of this angle, so cosine of B minus A, and then sine of B minus A. And then now we can just apply the distance formula again for these 2 points. And the distance must be the same as this distance. So then we can just set the 2 distances equal to each other. And then we can solve for the cosine b minus a. Okay? So we'll do the distance formula again for these 2 points now. So the difference in the x values, so cosine b minus a minus 1 squared, and then sine b minus a minus 0 squared. Right? So I'll square both sides to get rid of the square root, and then we'll expand. So we have cosine squared b minus a minus 2 cosine b minus a plus 1, and then we have plus sine squared b minus a. All right. So again, notice that we have cosine squared of b minus a and then sine squared of b minus a. And so b minus a, that's the same angle. So we have cosine squared plus sine squared of the same angle. So that's just equal to 1. So we have 1 from there. And then we also have plus this one. So then in total, we have 2 minus this. So we have d squared is equal to 2 minus 2 cosine b minus a. And this will be our second equation for the distance. However, we know that the distance between Q and P, this is must be the same. So this distance is the same as that distance, right? Because it's the same 2 points. So then we could set these two equal to each other. So let's see. So we have 2. So we can notice like the symmetricity between the two, because they both have 2 minus 2 times something, right? So that means that this must equal this. Okay, so then we could set those two equal to each other. So we have from the first one, cosine A cosine B minus sine A sine B. This is equal to cosine of B minus A. And so now we've basically just approved the identity. But the only thing that we have to change is that, okay, so notice that cosine of A minus B, this is the same thing as cosine negative B minus A, right? So if you distribute the negative, then you get A minus B. But then from our even odd identities, we know that cosine of theta, that's the same thing as cosine of negative theta. So that's why we can rewrite cosine of b minus a as cosine of negative a minus b, right? But then this is cosine of negative theta, and so this is just equal to cosine of theta. This is equal to just cosine of a minus b. And then, boom, we proved the identity for cosine a minus b, right? So it's equal to cosine a cosine b minus sine a sine b, as you remember. So then for cosine of a plus b, it's a pretty similar argument. The only difference in the end is that you get cosine, you get a plus instead of a minus, right? So I'll let you guys prove or like derive the identity for cosine of a plus b using this as like inspiration. Okay? Cool. So that's how you derive cosine a minus b. All right, so now let's derive sine of a plus b. So sine of a plus b, right? So from our cofunction identities, right? So from cofunction, recall that if we have sine of theta, this is equal to cosine of 90 degrees minus theta, as long as theta is between 90 degrees and 0, right? So that's from our cofunction identities. So sine of a plus b, we can rewrite this as cosine of 90 degrees minus this, minus a plus b. Okay, and so then we can rearrange the terms in here. So I'll rewrite this as 90 degrees minus a and then minus b. And so now notice that we have cosine of one angle minus another angle. So we just proved the identity for cosine of a minus b. So we can apply that identity here because now we're like sure like that's the identity. So we just proved it. So we can apply that identity here. And we know that it's a cosine of the first angle, so 90 minus a, times cosine of the second angle, so b, plus sine of the first angle, sine of the second angle. Okay? So then, again, from our cofunction identities, from cofunction, we know that cosine of 90 degrees minus a, this is exactly the same as just sine of a. and then we have cosine b, that stays the same. And then similarly, sine of 90 minus a, that's the same as cosine of a. And then sine b stays the same. And then this is equal to sine a plus b. So we have proved the identity. Right? And again, I'll let you guys derive the identity for sine a minus b. Okay? And then finally, we have, for some different entities, we have tangent. Okay? So now we must derive the identity for tangent a plus b. Okay? So just recall that we know that tangent of theta, this is equal to sine over cosine, right? So we're going to use the exact same principle here. So we know that tangent of a plus b is equal to sine of a plus b over cosine of a plus b, because we've already derived the identities for sine and cosine of a sum. So we can just use those to derive the one for tangent. So this is just equal to sine a cosine b plus sine b cosine a, as we just saw, over cosine of a plus b, that's equal to cosine a cosine b minus sine a sine b. Okay? And so now the trick is we're going to divide the numerator and the denominator by cosine a cosine b. So if we do that, so we're going to divide by cosine a cosine b, top and bottom, because this is just the same thing as dividing by 1, which doesn't change the original value. So this is legit. So in the top, we get sine a cosine b over cosine a cosine b. And then we have sine b cosine a all over cosine a cosine b, divided by, we have cosine a cosine b over cosine a cosine b. And then we have minus sine a sine b all over cosine a cosine b. All right. So we know that sine over cosine, that's tangent. And then cosine over cosine, that just cancels out, right? So cosine b over cosine b, it cancels. So sine over cosine, that's tangent of a. And then similarly, here we have cosine a over cosine a, that cancels. And then you have sine b over cosine b, that's tangent b. All right. Here we have cosine a cosine b over cosine a cosine b, so that's just 1. And then minus sine a over cosine a times sine b over cosine b. So that's sine a over cosine a, that's tangent of a. And then sine b over cosine b, that's tangent b. Right? And so now this is the identity that we got for tangent a plus b. So now we have also proved the identity for tangent a plus b. And once again, I'll let you guys derive the identity for tangent of a minus b. It's like the very similar setup, except you do use identities for sine of a minus b over cosine of a minus b, and you just follow as normal. All right, cool. So those were the identities for the sum difference. So now let's derive the ones for double angle. Okay. Okay. So let's begin with sine of 2a. So this is just the same thing as saying sine of a plus a, right? And so now we can just apply the sum identity for sine on this. So we know that this is equal to, so okay, so I'll just recall, so note that sine of a plus b, this was equal to sine a sine b, or sorry, sine a cosine b plus sine b cosine a, right? So we can just apply this to sine of a plus a. So then you get sine a times cosine a plus sine a cosine A, right? But this is just equal to 2 sine A cosine A. So that's how you get the identity for sine of 2A. Okay? And then now we have cosine 2A. So it's like the exact same thing. You just split this up as cosine of A plus A, and then you apply the identity. So I'll do another note. Cosine of A plus B. This one was equal to cosine A cosine B minus sine A sine B. Okay? So you get cosine A sine A, or sorry, cosine A cosine B, which is still A, minus sine A sine A. But cosine A times cosine A, that's just cosine squared A. And sine A times sine A, that's just sine squared A. So this is like the identity that you get for cosine 2A. But then remember that cosine of 2A has 3 different representations, right? It has 3 different identities. So this was one of them. So then how do you get the other 2? So we can use Pythagorean, right? So we can, so remember the Pythagorean identity that says that if you have cosine squared A plus sine squared A, that's equal to 1. So then cosine squared A must be equal to sine 1 minus sine squared A. So then we can substitute this in for cosine squared A right here. So we get cosine squared is just 1 minus sine squared minus the sine squared. And so then this is how you get the 1 minus 2 sine squared A. And that was the other one, and there's one more, and that's just by taking the Pythagorean and then solving for sine squared A is just equal to 1 minus cosine squared A, and then you could substitute this in for sine squared instead, so you get cosine squared A minus 1 minus cosine squared A, right, substituting that in for sine squared, and then if you simplify this, you should get 2 cosine squared A minus 1. So that's how you get the 3 different representations for cosine of 2A. Okay, so you have this one, then you have this one, and then finally this one. All right, coolio. And so then finally we have tangent of 2A. So I'll just erase. So we have tangent of 2A. And it's the exact same thing. This is just equal to tangent of A plus A. And then from our identities, we can get that this is equal to tangent of the first angle plus tangent of the second angle, all over 1 minus tangent of the first times tangent of the second. And so tangent A plus tangent A, that's 2 tangent A, and then tangent times tangent is tangent squared. And that's how you get the double angle identity for tangent. Okay, so I hope you guys enjoyed this video, right? I hope you guys enjoyed the derivations of all the trig functions and the identities. And if you did, please make sure to leave a thumbs up and don't forget to subscribe. I'll see you guys in the next video.